4.5 billion years ago, Earth was a world unlike anything we know today. Its surface was a vast ocean of molten rock, constantly reshaped by violent impacts, volcanic eruptions, and unimaginable heat. Yet within this chaos, the foundations of future continents were beginning to emerge. As Earth slowly cooled, the first crust began. This early crust was primarily basalt, a dark volcanic rock, similar to that found beneath today's oceans. Heavy rains fell for millions of years, forming the first oceans and creating conditions for a remarkable geological transformation. Deep beneath the surface, powerful convection currents moved through Earth's mantle. These currents drove volcanic activity and caused portions of the crust to melt and reform. Over time, lighter minerals rich in silica accumulated, creating a new type of crust that was less dense than basalt. This lighter crust was dominated by granite, a rock formed when magma cooled slowly beneath the surface. Granite contains abundant silica and large interlocking crystals. Because it is less dense than basalt, granite tends to float higher on Earth's mantle, providing the foundation for future continents. Over hundreds of millions of years, isolated fragments of granite-rich crust began rising above the oceans. These primitive landmasses, known as proto-continents,
represented the earliest ancestors of today's continents.
Driven by tectonic forces, proto-continents collided and merged. Each collision added new material to the growing continental crust. Mountains rose, ancient terrains stabilized, and Earth's first substantial landmasses expanded across the planet. Eventually, portions of continental crust became stable enough to survive for billions of years. These ancient regions, called cratons, remain the oldest surviving pieces of Earth's continents and can still be found today in places such as Australia, Africa, and North America. From molten chaos emerged the continents that shape our world today. The formation of continental crust, the rise of proto-continents, the creation of granite, and the stabilization of Earth's first landmasses laid the geological foundation for oceans, ecosystems, and eventually life itself.